Hello everyone, I am Meenakshi Chauhan, working as an assistant professor, Guide Group of Institution, Ghaziabad. In this lecture, I will be discussing about interfacing devices. So let's get started. So what is an interfacing device? An interfacing device is a semiconductor chip. It means it is made of semiconductor material. And these devices are needed to connect peripherals to the bus system. In computer, we have various components such as processor, memory, input, output, or bus system. So we need to interconnect those components. So for different purposes or several types of interfacing, we need interfacing devices to interconnect the components of a bus-oriented system. And commonly used logic devices for interfacing are tri-state device, buffer, decoder, encoder, D flip-flop. It can be latch or a cloud flip-flop. So we will see these devices one by one. First, tri-state device. Tri-state logic device, as its name suggests, tri-state. So tri-state logic device has three states: logic 1, logic high, logic 0, logic low, or high impedance state. Tri-state logic device also has a third line called enable. Enable line makes a device work its normal working. Otherwise, the device will be in high impedance state. When the enable line is active, the tri-state device functions the same way as ordinary logic device. When the enable line is disabled, the logic device goes into the high impedance state, as it were disconnected from the system. So here we are taking an example of tri-state inverter. It takes input X and converts this input into X bar. Here, tri-state inverter will show three states. If we give input 0, it will convert into 1. If we provide input 1, it will convert it into 0. When this enable line is active. But if this enable line is disabled, then the circuit behave like a disconnected circuit. No connection between input and output. This will be in high impedance state. So it will be considered as if it were disconnected from the system. So enable line can be active high line. It means this device will work if enable line is 1, or we can say enable line is at logic high. If this enable line is 0, then this device will be in high impedance state. Or enable line can be active low. You can see an inverter here. So if this enable line is 0, the device will behave as its normal operation. Otherwise, if the enable line is at logic 1, this device will be in high impedance state. So tri-state buffer shows three states: logic 1, logic 0 and high impedance state. Next device is buffer. Buffer has only a single input, a single output. It simply passes its input unchanged to its output. As you can see in this image, input X is transferred to output X without change. So buffer is used to introduce some delay. Buffer is used to amplify a signal. It converts a weak signal into a strong signal. A buffer is mainly used to increase propagation delay. So it introduces some propagation delay in input and output. Buffer can also be enabled. Here, this enable line is active low line. So this buffer will work when enable line is 0, or if will not work when enable line is at logic 1. Next device is decoder. A decoder is a logic circuit that identifies each combination of input signals present its input. So it recognizes n bit encoded input into one of 2 to the power n outputs. So decoder is used when we want to convert binary information from an input line to a maximum of 2 to the power n unique output lines. Commonly, decoder is used in interfacing I/O peripherals and memory. Decoder is used to decode address buses to identify whether it is I/O device address or a memory location address. For example, if we take 2x4 decoder, so this decoder will have 2 inputs and 4 outputs, and 2-bit encoded input will be decoded one of 4 output lines. So this decoder will make one output line active and other inactive based on n bit encoded code at its input. So decoder is used to identify the address to address some memory location or input output device. What is an encoder? Encoder is reverse of decoder. So encoder is also a logic digital circuit that provides appropriate encoded code for each input signal. And this code can be a binary code or BCD code. So as you can see in this figure, this general encoder has dimension 2 to the power n to n. It has 2 to the power n inputs, and one input out of 2 to the power n inputs will be encoded into n bit code. For example, if we use an encoder with keyboard, so for each key pressed, the corresponding binary code is placed on the data bus. So one of the keys will be encoded in some binary code. And for this purpose, we will have an encoder. Next is D flip-flop. It is also known as data flip-flop or delay flip-flop. Flip-flop or latch is a circuit that has two stable states. It means it can store 0 or 1. It can show a state 0 or state 1. And this device can be used to store state information. It can store bit 0 or bit 1. Now, what is the difference between a latch and a flip-flop? So, in latch, in this figure, you can see that this latch has enable signal. And this enable signal is label sensitive. Label sensitive means here we have a clock. This clock pulse has level 1. This is level 1. This is level 0. This is positive edge. This transition denote negative edge of the clock. So latches are level sensitive. It can be level 1 sensitive or level 0 sensitive. Here in this diagram, you can see that we have input D. And D flip-flop works, the input will be transferred to the output as it is. this input is 0, then 0 will be transferred. If it is 1, then 1 will be transferred. Here, input signal, we have input signal, and the latch output will depend on the level. If we assume that this latch is level sensitive latch, so this latch will sense to level and will provide the output according to this level and input. So here you can say that continuous change in output during this level 1. Here for level 0, the output remains same until level 1 arises. So here you can notice the change in output due to level 1 and input D. So when level 1 exists, the input is transferred to the output. But in flip-flop generally are edge triggered. Edge triggered means this flip-flop will work on either positive edge of the clock or negative edge of the clock. So here you can see the change in the output. We assume that the flip-flop is positive edge trigger. It means flip-flop will work when the positive edge of the clock occurs. So in this diagram, we have positive clock here and positive edge of the clock here. So here you can see that the input is 0 and positive is trigger the output to be 0. This output remains until next positive edge. Here you can see that input is 1, so the output will also be 1. And this output will remain until next positive edge comes. So latch is level sensitive, whereas clock is edge sensitive. Latch commonly used to interface output devices. When microprocessor unit sends output data on a data bus, so data are available for only few microseconds. So we need some device which can hold the data for display. So latches are used to hold data for display. So difference between D flip-flop and latch. Latch is level sensitive. It can be level 1 or level 0. Or flip-flop is S trigger. It can be positive S trigger or a negative S trigger. The content of this lecture was taken from Microprocessor Architecture Programming and Application with 8085 book written by Ramesh S. Goankar sir. You can refer this book for more details. Thank you. Happy learning. Take care.